Hello all, greetings of the day. Myself, I am Erapaneni Gayatri, Assistant Professor in the Department of CSE, Madanapalle Institute of Technology and Science. Today we are going to see about the Introduction to Convolution Neural Networks and its applications. Today, my flow of presentation will be like this. Before going to see about the convolution neural networks, we are going to see about the deep learning, the key features of deep learning, and machine learning versus deep learning, core component of deep learning. Then we will move on to the introduction to convolution neural networks and finally applications of convolution neural networks. Coming to the introduction of deep learning, in the AI, deep learning is a subset of machine learning. Which itself a branch of artificial intelligence. Mainly, it focuses on the algorithms which are inspired by the structure and functionality of the brain. It means that it is going to mimicking the human brain, called the artificial neural networks. These artificial neural networks are powerful tool when we are going to work out with the large and complex data sets. Here in the deep learning, it is going to learn the features automatically from data. Coming to the key features of the deep learning, it is going to follow some features. Those are nothing but hierarchical learning, end-to-end learning, and finally massive data and computational power. The first one is the hierarchical learning. Here deep learning models represented in here in the deep learning models, the data is represented in the layer wise. In this layer, the lower layers are going to capture the basic features such as edges of an image, and while moving on to the higher layers, it is going to learn the some abstract features. Those are nothing but shapes, objects, and are some even faces also. Next one is the end-to-end learning. In the deep learning model, the input is the raw image, and after that, after giving the input, it is going to learn the features without any necessity of manual feature engineering. It means that in the deep learning models, we are not going to perform manual feature extraction. It is going to done automatically by the deep learning models. For example, a deep learning model is going to identify object in images directly based on the pixel values. When we are working with the deep learning model, the main advantage is here we are going to work out with large amount of data sets or complex data sets. So here the deep learning thrives on large data and it requires the significant amount of computational resources. Obviously, when we are working with the high computational high data sets, obviously we need the high computational powers such as GPUs and TPUs. Here GPUs are nothing but graphics processing units and TPUs are nothing but tensor processing units. Those are required for the training process. This is the key difference of the machine learning versus deep learning. In the machine learning, coming to the first one, learning approach, in the deep learning we are going to deep learning algorithms are going to mimic the human brains, so it is going to learn the complex neural networks. And coming to the machine learning, it relies on the statistical models and algorithms. And come next aspect is the feature extraction. In the feature extraction, in the deep learning algorithms are going to automate the going to extract the features automatically without any human intervention. In machine learning, manual feature engineering is required. Here, first we are going to give the input, then we are going to perform the feature extraction manually. After that only machine learning algorithm is going to perform the task. Next one is the data requirement. In the data requirement, when we are working with the deep learning models, a large data sets are required for accurate output or predictions. But in machine learning, a smaller data sets are sufficient to perform the particular task. Coming to the computational power, obviously when we are working with the higher amount of data, a high computational power is required. So whenever we are working with high computational power and a large amount of data, it takes the more training time. So coming to the machine learning, here we need the less computational power and training also faster. Coming to the applications, in the deep learning, we are going to perform the applications like image recognition, natural language processing, and speech synthesis. Coming to the machine learning, here we are going to perform the some predictive tasks and recommendation systems and fraud detection also. By observing this diagram, the first one represents the machine learning and the second one represents the deep learning. In the machine learning, if we observe, first we are giving the input image, then we are performing the feature extraction. We are going to extract the feature of that input image. After that, we are going to perform some machine learning classification, machine learning algorithm we are going to use for the classification. Finally, we are going to classify as car, as no car. Coming to the deep learning, just we are giving the input image. After that, we are using the deep learning model for feature extraction and classification. Here we are not doing any manual feature extraction. Finally, output is classifying the image, whether that given image is car or not car. Next, this is the necessity of the deep learning. The first one is the accuracy. Here, always deep learning often outperforms traditional machine learning methods in tasks involving unstructured data. Especially this deep learning is using for the images and videos also, images, videos, audio and text also. Next one is the scalability. Deep learning models can be able to handle enormous data sets. Enormous data sets means here we are going to use various types of data sets. Next one is the adaptability. When we are making any changes, these deep learning algorithms can be able to adopt the changes in that images or input. Coming to the core components of deep learning, there are several core components are there. First one is the neural networks. Here neural networks represents the layers of neurons. Here each neuron performs some specific task in terms of computation. First it receives the input. After that it is going to apply some weight. We are going to sum those weights. Finally we are going to pass the result through an activation function. Where there are various types of neural networks are there. The first one is the feed forward neural network, and second one is the convolution neural network, and third one is the recurrent neural network. The first one is the feed forward neural network. Here in the feed forward neural network, the input, the data is going to pass in only one direction, which is the forward direction from input to the output. Next one is the convolution neural network. These convolution neural networks are specially designed for the image data. And third one is the recurrent neural networks. Recurrent neural networks means it is specially designed for the sequential data. Those are nothing but text or time series. Activation functions. These activation functions will be helpful for adding the non-linearity to the network so that we can enhance the complex mappings. There are various activation functions are there. Those are nothing but ReLU. ReLU is nothing but rectified linear unit, or ALU also there, and sigmoid and tan H. These are the various types of activation functions. Coming to the loss function, these loss functions will play a major role to measure the difference between the predicted output and the actual output. Then only we are going to identify the how much error is occurred. There are various types of loss functions are there. When we are performing the regression task, we are going to use mean squared error. When we are performing the classification, we are going to use the cross entropy loss. Final one is the optimization algorithm. These optimization algorithms adjust the weight of the network to minimize the loss. By using the optimization algorithms only, we are going to reduce the loss. There are various types of optimization functions are there, like gradient descent, adaptive moment estimation, or else ADA grade. Like that, many activation functions are there. Now moving on to the introduction to convolution neural networks. Generally, a convolution neural network is a type of deep learning neural network architecture. Basically, we use the CNN in the computer vision. Computer vision, it is a field of the artificial intelligence that enables a computer to understand the images or input, and so that it is going to interpret the image or visual data. Coming to the architecture of CNN, the first one is the input layer. After giving the input, that input is moving on to the convolution layer. Convolution layer is the key step in this architecture. After that, we are performing the max pooling. Finally, dense layer. Finally, it is going to give the output. Coming to the input layer. Generally, the input layer is going to accept the raw input data for processing. Mostly, when we are working with the CNN, mostly the input data will be a image or a sequence of images. After that, the data will be a multi-dimensional array. For suppose we are using the grayscale image means it will have in the one channel, only one channel in the grayscale image. So we are representing that grayscale image as height cross width with one channel. If it is the color image, it is having the three channels, which are nothing but RGB channels, height, width into 3. Next one is the convolution layer. Convolution layer, this is the key step in the entire process. Here we are going to Here we are going to extract the features from input data by applying the filters. Filter or kernel. Here a filter is nothing but it is a m by m multi-dimensional matrix. With that matrix are smaller matrices, usually either a 2 by 2 or 3 by 3 or 5 by 5 of shape. This kernel is going to slide over the input image data. Finally, it is going to compute the dot product of kernel and the corresponding input image patch. Finally, the convolutional layer is going to give the feature maps of particular image. Next, coming to the pooling layer, the output of the convolution layer is fed into the input as the input of the pooling layer. This pooling layer is going to reduce the dimensionality of the particular generated feature maps. So, the main function of this pooling layer is to reduce the size of the volume, which makes the, when we are reducing the size of the volume means automatically computation will be fast and it is going to reduce the memory also. Finally, we are going to prevent the overfitting. By observing this diagram, this is the first one is the input image. This is nothing but that is the output of the fully convolutional layer. Here we are going to perform the max pooling. Here max pooling is there, average pooling also there, but here we are going to perform the max pool with 2 by 2 filters. Suppose if we observe the first grid, the values are 1, 1 and 5 and 6. In that, the maximum value is the 6. That 6 will be the output of the max pooling layer. And same like that, next one is the 2, 4, 7, 8. 8 we are going to print. Like that, that is the output of the pooling layer. Next one is the flattening layer. In the flattening layer, the resulting feature maps will be flattened with a one-dimensional vector after the convolution and pooling layers. So, the information will be completely classified as the either categorization or regression. It is the next is the fully connected layer. It is the it takes the input from the previous layer, which is nothing but it takes the input from the previous layer. Finally, it is going to perform the either classification or regression task. Then the output of fully connected layer is connected to the output layer. The output from the fully connected layer is connected to into the logistic regression for classification task. In this, we are going to use two activation functions, either sigmoid or softmax. When we are working with the binary data, we are going to use the sigmoid activation function. When we are working with the multi-class classification, here we are going to use the softmax activation function. These activation functions converts the output of each class into the probability score of each class. Coming to the advantages and disadvantages of CNNs. The advantages of CNNs are it is very good at detecting patterns and features in images or videos or audio signals. It is very robust to the translation or rotation or scaling invariance. We can perform any task for the image. Finally, it is going to the CNN are following the end-to-end training. So in the CNN, there is no need of manual feature extraction. Automatically, deep learning algorithm will performs. It is going to handle the large amount of data. So it achieves the highest accuracy. When the data is passes into these CNN layers, the complexity will be the increases. So the model can able to learn the more abstract features. Coming to the disadvantages of CNNs, obviously when we are going to work out with large amounts of data, so computationally we need the higher resources, so it is the computationally expensive to train and it requires a lot of memory also, and it is very hard to understand what the network is learning during the training process. Whenever the class imbalance is there, the model can be prone to the overfitting. When it is overfitting means there is no enough data or proper regularization is used. Requires a large amounts of label data also. Coming to the applications of convolutional neural networks, the first one is the image and video processing. In that, we are going to perform various tasks. Object detection. If we want to detect any object, any object in particular images or videos also, we can use CNN. For example, YOLO, you only look once, or SSD also we can use for object detection. Next one is the image classification. Here we are going to identify a class of objects in an image. The default data set is ImageNet challenge. And next one is the segmentation also we are going to perform. Segmentation is nothing but dividing the foreground and background of the image. Next one is the face recognition. In the face recognition, we are going to identify the individuals in the images or videos. Finally, we are going to apply the style transfer. Next application is the healthcare. In healthcare also, we can perform many tasks also. First one is the medical images, medical image analysis. Here we are going to detect the diseases by using the X-ray images, CT scans or MRIs. Next one is the disease prediction. Here we are going to analyze the various features which are non-invasive disease detection. Non-invasive means like diabetes or Parkinson's disease. We are not going to identify that much easily. Next one is the tumor detection. Tumor detection is nothing but those are nothing but cancerous tumor or benign tumor. So identifying the malignant or benign tumors in the medical images. Next one is the paddy disease detection also. In agriculture also we can able to identify the some diseases. These are also various types of applications, nothing but autonomous systems and NLP in cyber security. In cyber security also we can identify phishing pages and email is spam or not, like that and all we can identify in the cyber security. Next is the entertainment and media, and last one is the sports and fitness. In the sports and fitness also human activity recognition can be identified using the CNN, yoga posture recognition, all those things. There like this there are various applications using of convolution neural networks are there. These are the references which I had gone through. Finally, thank you.